All right. Good morning, good afternoon to whenever you're watching this. Just first say thank you for taking the time to look at this, take the time with this presentation. I'm going to just use the time here to go briefly over something that's been a real focus of ours in the science department through to secondary with Ms. Parkinson. And that is this idea of working scientifically. So for those that don't know me, I am Mr. Lucas, John Lucas. I've been the head of primary science for 3 years now. It's my fourth. And we have, a lot's changed in that time. But like I said, working scientifically and making that path all the way up to secondary is something that we've been starting to implement as low as FS now. So these kind of core skills are what we're hoping to see for students all the way through the school and built upon as we go. So I'll give you more information as we go. So what does it mean to work scientifically? Well, working scientifically, simply put, are a set of objectives that have been built upon in order to make sure that children aren't just understanding scientific knowledge, such as, for example, the heart or the light or sound or that particular scientific theory, but it's actually their ability to work scientifically and to carry out investigations, to be able to present conclusions, present results, be able to draw upon predictions from learning. So it's really kind of the glue that binds all of that scientific learning together. Now, what I've got up here for you, don't worry, I know I'm not going to play PowerPoint karaoke with you, but I will give you guys a chance to send these out. You can find them online, but these are the working scientifically objectives. Like I said, they're split into the three kind of different age groups. So obviously Key Stage 1, Year 3 and 4, and 5 and 6. So you can see there Upper Key Stage 2 and Lower Key Stage 2. And the thing you need to know really is that they're very repetitive. So it is a set of sort of strategies and skills that the children should build in order to justify their scientific knowledge, but building in terms of engagement, in terms of expectation, and that kind of difficulty level. So if we look, for example, at Key Stage 1 here, you can see performing simple tests. A child who is entering Key Stage 2, that Year 3 child, with the hope that they could start to put together simple ideas for what does an experiment look like. And, if I wanted to show something, what basic equipment might I use? For example, observing closely using single equipment. And you can see as we move up to Year 3 and 4, that then becomes setting up practical inquiries, comparative and fair tests, going all the way up to Year 5 and 6, where they're planning different types of inquiries around specific questions and considering the different variables. So you can see that it's a very similar skill, it's just slowly building as it goes up through the school. So these objectives are available online. At the end of this presentation, I'm going to leave you with my email address. I've put together a little pack that, again, if you guys want a copy of, just to have a look at what those expectations are, maybe kind of think about how when children are working at home with you, not just during this digital learning time, but in general, that how you can kind of push those further forward. Of all the subjects we see, my experience, especially as a teacher here at WEC, has been that children are most engaged with science outside of school, and it is the one subject they tend to pursue and kind of do that deeper learning and that further research into. So again, any support that's guided at home, hopefully this will help you a little bit. So we're going to have a look. I created these a couple of years ago. We use them frequently in lessons. Now, one of the different structure changes which we brought in a couple of years ago is obviously we're very lucky to have our incredible primary lab set up as of the beginning of this year and towards the end of last year, and being able to provide that resourcing, but that specific laboratory Sorry, I'm going to make a lot of mistakes today. This is all unscripted. But that particular laboratory setting, which allows the children to remove themselves from the classroom and really engage with that scientific experience. And part of that was that, as well as having content to measure. And the one thing you need to know is the content for different modules, it changes. So, for example, as we speak, my Year 4s are currently studying animals and humans. That's only 3 objectives. But, for example, Year 5, who are studying materials, have 6 objectives. So it's very varying in time. Equally, some specific modules allow them, lead themselves very well to investigations. So things such as in Year 3 and forces, looking at materials and flammability in Year 2. However, things like Year 6 topics, such as looking at their life and living processes, same for Year 4, is very theoretically based around pollution and around climate change. So again, investigation, we're trying to fit as much of that in, and we are really encouraging the teachers and seeing great results from the kids being very hands-on. So that idea of having a 1-hour lesson of theory supported by a 1-hour lesson around activity. Now that might be classroom-based activity or it may be lab-based. But when it is lab-based, we encourage and have been using these. So these are our scientific investigation plans. So on the left-hand side, you will see the Key Stage 1 investigation plan, and on the right, you will see the Key Stage 2. Now, these were broken down by me into the main sections that those learning objectives target. Okay, and they can be summed up in a few simple words. So I'm going to go through them here. First one is line of questioning. So what comes up again and again is the children's ability to understand why. Why are we doing this investigation? What are we trying to find out or test? So in upper Key Stage 2, you will see here we use key questions. We call them key questions. Children are expected to write open-ended key questions. But for example, with Key Stage 1, what are we trying to find out? And then the teacher will use that as a deeper learning challenge to say, well, okay, you're trying to find out if something burns or not, if something is flammable. How could we turn that into a question? And obviously, it's in line with their English objectives as well. So it's about building as we go along. So it's always about a line of questioning, about the method of investigation. So we're very much focused when talking to Key Stage 1 teachers about equipment and learning about scientific equipment, what's available to them. If I want to measure temperature, what equipment do I use? We may take for granted in Key Stage 2, well, they use a thermometer. But we need to remember Key Stage 1 children don't have that experience yet. So it's very much Key Stage 1 based around what equipment are you going to use and why. But when we get up to Key Stage 2, obviously we can go into that proper technical vocabulary of method and of course the idea of a variable. Now, for those of you that don't know, a variable is the thing that changes. So for example, if I am measuring how the temperature of water and how it affects salt dissolving, my variable will be the temperature. If I measure a teaspoon of salt in water 5 times at the same temperature, it doesn't give me anything different. However, we want children to record, well, actually, okay, if I'm measuring the temperature, then I need to do it at 20 degrees, 30 degrees, 40 degrees. And that will then lead on to those results. So method's really, really important because also when you get to Year 5 and 6, you're starting to think now about what is appropriate to use. So something that came up recently was, again, like I said, use of thermometers. And okay, can I use a thermometer if something is boiling? Well, that's dangerous. I'm not going to put a thermometer in boiling water. I'm going to use, for example, some of Rachel Parkinson, head of secondary. We have a great relationship with them that introduced us some of their metal thermometers and their digital thermometers. How can we use more efficient equipment? How does the equipment outlay our particular task? So it's, again, all worth thinking about. And then we come to predictions. Now, predictions is something which we don't do a massive amount in Key Stage 1 because the knowledge isn't there. Obviously, they've only had technically a year, 2 years worth of engagement with it. So that's led through kind of deeper learning challenges in Key Stage 1. But in Key Stage 2, we would expect children to have enough scientific knowledge to be able to start making conclusions of their own. And again, what's really important is that our teachers are constantly engaging this with the UAE and with daily life. So when we do electricity in Year 4, we talk about what's battery operated and what's mains operated. So children are having to think, okay, if something is mains operated, we have a plug, we plug it into the wall. Okay, what are the safety risks involved? So they understand and use their knowledge, and that's what we want for our predictions. So children being able to make predictions, but also because they offer a really good basis for reflection. And obviously a large part of the WEC learner profile is that reflective learner is going back and saying, okay, well, I thought material X was going to be flammable, was going to burn in 5 minutes, but it didn't. Why did I think that? Well, okay, so how have I corrected my knowledge? So really important predictions. And then results. So obviously we do that in Key Stage 1, thinking about what do your results look like? What did you see? Obviously making it a very visual appearance, drawing pictures, diagrams, things like that. But when we go up to Year 5 and 6 especially, we're starting to look then at graphs and tables and scientific diagrams. Now, one thing that came up when we've done a lot of work, as I said, with secondary in terms of almost designing the perfect science student to arrive in year 7. And what do they want? And one thing that came up was things like graph knowledge and maths connected curriculum links, so that we can now make sure that children from year 4 are starting to put their results into diagrams. So that when they get to year 7 and they are plotting proper chemistry, biology and physics investigations every single lesson, they are not worried about these key skills. So results is more than just showing what you can do. Now, one thing I would say in general, children aren't very aware, and the more you guys can do at home in terms of what is a table or building tables is something that we often have to repeat because we find children struggle with this. So again, that results gives them a specific section to say, I'm not asking you why this happened in your investigation, but I'm saying to you, how can you show me? So show me your data. And then finally, the most important one is your conclusion. Now this links with that idea of 1 hour of theory, 1 hour of investigation, is that whether it's year 1 or year 2, Key Stage 1 or Key Stage 2, we're using scientific vocabulary and theory from those lessons to develop and build this understanding, so that children are now more than capable of looking and saying, okay, we're not just saying I melted the chocolate and it melted. Why did it melt? Oh, okay, well, we know this is a reversible reaction. This was a reversible reaction because, and again, really developing children to understand those conclusions and link it to their scientific knowledge. It's the golden question I ask my class 100 times a day. Why? Okay, every single time you write something in your book, I want you to write the word because you are going to justify your answer. You can't just tell me what happened, that's your results. Your conclusion is where you've built on it yourself. Now, I realize that is a lot of information to throw at you, and I apologize. Obviously, we've got a limited amount of time here for this, but what we're looking at and what I'm really impressed by so far are those children and the way they have adapted to this. So the kids really are understanding more, they're using that lab time more productively. So any kind of support we can offer you guys in understanding and working at home, and not necessarily conducting those investigations, but just referring their scientific knowledge to the world around them, because that's one of the biggest parts, especially down in FS, that understanding of the world around us. Anything extra we can do to help, please, just don't hesitate to ask the class teacher. They have access to all the resources. My email address is here as well. If you'd like some extra information, I've got some, not only have I got these working scientifically grids, but also we have key vocabulary packs, and we have, I've lost my words, not biography, glossary packs as well for working scientifically and being able to go through those objectives. So please, don't hesitate to contact your class teacher or myself. They will put you through to me. And if there's anything else we can help with, just let me know. But, thank you for taking the time. We really do appreciate it. I know it's been crazy with the digital learning, but, the one thing I can tell you is, as the person who analyzes the data, our kids in primary are just really loving science. They are really loving that subject. They're loving spending that lab time and really finding those greater depth challenges. So any way we can kind of, enthuse about that and build on that, that's just a win-win as far as I'm concerned. So thank you for your time. Enjoy the rest of your day with the ACE conference. And if you have any questions, my email is on there. All right. Thank you very much.